How do self-driving vehicles detect other cars, obstacles, and street signs? Those remarkable capabilities are made possible due to convolutional neural networks, a type of neural network that has revolutionized image recognition and classification. Before we get ahead of ourselves, let's introduce artificial intelligence, or AI. The ever-growing field of AI emulates human intelligence and allows intricate problems to be solved more effectively. A neural network is a subset of AI that extracts features from datasets and imitates the neurons of a human brain. Let's take a closer look at a CNN model. CNNs have three layers: the input layer, the hidden layer, and the output layer. Think of the process as making a cup of coffee, where the input layer is the coffee grounds, the hidden layer is the machine, and the output layer is the cup of coffee. Between each neuron is a connection that holds a unique weight value. In each neuron of the hidden layer, the products of the input neuron's RGB value, x, and the weight are summed. The neurons in the hidden and output layers also have bias values, which are added to the sums. The hidden layer is often comprised of multiple layers, depending on the intricacy of the model. So, what makes a CNN different from all the other neural networks? A CNN has a unique layer called the convolutional layer. The filters in the convolutional layer are different from those of other neural networks in that they can find and recognize specific features anywhere in the image, not just in a specific area. Let's look at a real example, something simple like handwritten numbers. How does a CNN know that these are 8s? The image is a compilation of pixels, and the filters in the model's convolutional layers detect features and patterns by sliding through the width and the height of the input image. The mathematical process is a dot product. Each corresponding value on the filter and image is multiplied, added together, and divided by the number of pixels in the filter. This process creates feature maps that show the relationship between neighboring data on the input image. Using what it has learned, the CNN will be able to recognize the two loops that make the shape of an 8 and correctly classify it when tested. Of course, complicated tasks require multiple convolutional layers, which create more feature maps for feature extraction. They are followed by activation functions and pooling layers, which reduce the amount of computation. So the next time you see a self-driving vehicle, think of the million of object-detecting neural connections that allow the car to operate and make smart decisions.